Uh, yeah.
Hi.
Hey, hi. What's up?
Nothing much. What about you?
Yeah, I'm good. Wonderful. So, what is the time in your zone? What is the time now?
11:30 in the morning.
11:30. Cool.
Yep.
So, we were discussing about the energetics term, right?
Yeah. Yeah.
Okay.
Yeah. So basically, can I just share my screen really quickly?
Yeah, definitely. You can say anytime.
You've disabled it.
I have to. Okay. Means I have to stop sharing, right?
Yeah, and also able my screen sharing.
Okay. And from where? From where I need to start? Means I have to give you permission to share your screen. From where I
Yes.
will get? From where I will get this option?
I think it should be like near the video screen thing at the bottom.
Okay. Okay. I made you host, so I think now you can do. Now you can share.
I can share now. Okay, so I just like I looked through the curriculum and stuff, so I just wrote some stuff down to
Mhm,
make sure that we're doing stuff that I need.
mhm.
So this is basically like all of my units, and this is like the stuff that is in the units. Um, yeah. And then this is like, so basically we have a revision textbook. And so this is just like a quick review notes of everything I'm gonna need for this particular chapter. And
Mhm.
I put like little pictures of that here. It's just 2 pages.
Okay.
So I just
Cool.
wanted to show you that. Yeah. So it's just this. Is that good?
Yeah, yeah. I'm able to see that. Right.
Great.
Okay. Hmm.
So can we just start with something related to that?
Okay. Cool. We will begin with that
Great.
only.
Okay.
So just let me put my charger.
Words.
So, as I have seen your stuff, it was more about the enthalpy. You are more, more interested in enthalpy. So we will discuss the enthalpy.
Okay.
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 I think. I think now I have to. I have to share my screen, but
Yeah.
host disabled participant screen sharing. You have disabled.
Okay. I'm gonna able it.
Okay.
You should be able to do it now.
So we were discussing about the enthalpy term. Right? Yeah. So
Yep.
there are the kind of reactions in which we need to follow the reactions. Okay,
Okay.
we will discuss that. Endothermic reaction,
Yeah.
and then other one is the exothermic.
Okay. Yeah.
Okay,
Yes.
so what is endothermic reaction? Endothermic reaction is the reaction which accompanied by the absorption of heat, where heat
Yeah.
absorption takes place. Okay, suppose you have to dissociate calcium carbonate. It is the like limestone. It's like a
Okay.
limestone. If you want to decompose this, then you have to provide heat. You have to provide heat, and once it will be heaten up, it will be breaked into calcium oxide plus carbon dioxide gas. So this reaction is the endothermic process. Okay.
Okay. Yeah.
Here enthalpy is positive.
Yeah. Okay.
Okay.
So
Yeah.
enthalpy is the internal energy stored in the reactants, right?
Right. Enthalpy is the internal energy stored in the reaction at constant pressure. The pressure has to be constant.
Okay. And so in an endothermic reaction, because heat is used, the enthalpy is positive because there's more heat in the reactants.
Which,
Because the reactants are heated.
yeah. Enthalpy is positive. I'm talking about the enthalpy. As you told entropy,
Okay.
you told entropy or enthalpy. Enthalpy
And
term,
enthalpy.
yeah, enthalpy. So enthalpy will be constant in endothermic, will be positive endothermic process, because
Yeah. Yeah.
enthalpy of reaction is the enthalpy of product minus enthalpy of reactant. Okay, and the enthalpy of reactant will be more as compared to product. So product will be less. So that will be the enthalpy of product and minus reactant. So it will be positive value, because more heat required at the reactant side to complete the reaction. So it's a positive value.
Okay.
Positive value means heat absorption.
Heat absorption. Positive. Okay.
Yeah.
Enthalpy.
And I can give you a live example. Suppose you are in a desert place, right? There is a lot of desert. There is no trees. So you will feel more of heat. But when you goes to near, beneath of tree, nearby tree, you will start feeling little coolness in the temperature. Little dip in the temperature. Temperature starts dipping. What is the reason
Yeah.
behind that?
Because there's shade.
Because no, not like that. It's not said. Actually, the plants
Yeah.
are undergoing the endothermic process. What they do, they absorb the sun energy. They
Yeah.
absorb the sun energy, and they undergoes the photosynthesis process.
Yeah.
Photosynthesis process, they convert sun energy into food.
Yes.
So in this process, energy is being absorbed. Once energy is being absorbed, you will feel like cold. You will feel like cold, dip in temperature.
So because the products will be colder.
Colder, yeah.
Okay. Right. Cool. Okay. Great.
Okay. And
Yes.
what about the exothermic process?
That's when heat is released.
Yeah, when heat will released, like a combustion process. All combustion reactions are exothermic. What is combustion reaction? Combustion reaction is the reaction of any substance in excess of oxygen. Like methane gas, when burns in the excess of oxygen, it forms carbon dioxide and water.
Combustion reactions are the reactions of any thing in the excess of oxygen.
Yeah, a reaction of any substance in the excess of oxygen. So on complete combustion, hydrocarbon, देखो, see, methane carbon compounds are hydrocarbons. So hydrocarbons on combustion produces carbon dioxide and water gas, steam.
Okay.
ठीक है?
Mhm.
So it will be the delta H value will be negative value.
Are you writing anything on the board? Because I can't see it.
Yeah, I'm writing in the board. Can you see the things on the board?
Cannot see anything.
Everything is blank. Endothermic, exothermic. I have wrote a lot of the things here.
I can see a black screen.
How? I think now it's okay.
Nope.
Now are you able to see that?
Nope.
Still, there is no.
Nope. Okay, yeah, I can see it now. Kind of. It's blurry.
Blurry. Now it's okay. Actually, it's blurry.
Yeah, it's still blurry.
Yeah. Now are you able to? I think now it will be visible.
Okay. Yeah, it's visible now.
Okay. Cool.
Thank you. Okay, great.
So
Okay.
delta H enthalpy will be negative for this process.
Okay, negative. Because heat is released and therefore they
Therefore, you will feel heater in the atmosphere. If suppose there are the lot of person in a single room. Suppose you are having a single room and your 20-30 friends come inside the room. So this human body is exothermic in nature. We liberates heat. All the process in the body is the exothermic process. Whatever we do, we liberate heats. Once we liberate
yeah.
heats, that means it's an exothermic process. So more person in the room, more heat in the room, you will feel hotter. The temperature will increase.
Okay.
Got it?
Okay, yeah. Yeah. Got it.
Okay, right. So this is the exothermic process when heat will be released into the atmosphere. Okay.
Mhm.
So for exothermic process, delta H is negative. Heat of product will be more compared to reactant. And combustion process is exothermic, and the neutralization process of acid plus base, the reaction of acid plus base, reaction
Mhm.
of acid plus base is also an exothermic reaction. So the neutralization process is also an exothermic process.
Okay. Because heat is released in that process.
Yeah, that's right.
And heat is released in that process. Okay.
Heat is released because H plus and OH minus combined together. So when two ions combine, two charge species combined, means heat will always released.
Right.
Okay.
When
Two charge species. When the two charge species cation or anion combine, heat will always be released.
Okay. Okay.
So you want to pen down all things? I think you would have pen down, right?
Yeah, I wrote it down. It's good. Thank you.
Okay. Yeah, welcome. Now, if we are going to form the ionic compound means NaCl. So
Mhm.
cation Na plus and anion Cl minus combine together and they form NaCl solid. So this is also a exothermic process. Heat will be released. Can you do one thing? The kind of stuff you have shown me in
Yeah.
your Gmail or Gtalk. Can you share that stuff here? It is possible to share.
Yeah, sure. Like the link, I can send the link.
Yeah. I will make you host and then you can upload the stuff. Okay. Let me do that. Maya. I think you are the host. You can share. Upload. You can upload.
I can put the link in the chat and also I can do that.
Yeah, I have got this link. Hess law, average bond enthalpy. Okay. Okay, so here Hess law already being completed. We have done the Hess law, and then we will
Can I
have a
just have 1 second? Can I just
yeah,
have 1 second?
yeah, definitely go. Just
I'm back. Thank you.
you're welcome.
Right.
Okay. So we have discussed the Hess law in the previous class. Today we will have the questions on Hess law. Okay.
Yeah, sure.
Hmm. So are you able to see this question?
Yeah.
Okay. So now try to solve this question.
Okay.
Calculate the standard enthalpy change. Okay, let me put here. When 1 mole of methane is formed, when 1 mole of methane is formed from its elements in their standard states, the standard enthalpies of combustion of carbon, hydrogen, and methane are this much. Okay. So you must have an understanding how to read the data, how you can read the data and you can mine the data. So you have to be very good in the data flow. So in this question, the data they have given is like this. We have to calculate the standard enthalpy change when 1 mole of methane is formed. So methane is formed from carbon and hydrogen. Carbon will be a solid, hydrogen will be in the gas form, right? And it would be a methane gas, right?
Yes.
Okay, cool. And again, they have told enthalpy of formation means its constituents elements should be in most natural stable form, natural occurring stable form. So carbon in nature occurs as solid and hydrogen in nature occurs as gas, right?
Yeah.
Yeah, okay. And then they have given the standard enthalpies of combustion. So combustion means reaction with oxygen of carbon. Carbon react with oxygen, forms carbon dioxide gas. Okay. Hydrogen reacts with oxygen, forms H2 reacts with O2. It forms H2O. Okay. Here you can take 2H2 plus O2 gives 2H2O. Okay.
Yeah.
Is that clear?
Yeah.
Okay. Or even you can, okay, 1 mole of, we have to always form 1 mole. So 1 mole means we should not go for the 2 mole because enthalpy is always defined per mole. Per mole means for 1 mole. So we have to take half O2 gives H2O, right?
Yeah.
Got it?
Yes. Okay, so basically this, yeah.
Yeah. What's the doubt?
What are we doing right now with the carbon and hydrogen?
Okay, cool. What we are doing? We are doing with this question. What they have given in the data. They have given the heat of combustion, enthalpy of combustion for hydrogen, for carbon, and for methane. So for
Okay.
combustion means we have to react with the oxygen, and we have
Oh,
to
yeah.
we have to make the 1 mole, right?
We have to make 1 mole of whatever is formed when these things react with oxygen.
Right.
Okay. Cool.
Okay. So here we have to write down the 1 mole of H2O. So H2 half O2. Half O2 gives H2O 1 mole. Okay? Enthalpy of combustion. Now also they have given the combustion of methane. Methane means CH4 reacts with O2, forms CO2 plus H2O. Okay?
Yeah.
So these are the reactions they have given, and the data for this combustion of carbon dioxide, combustion of carbon they have given -394, and hydrogen they have given -286, and for methane they have given -890. Can you see that?
Yeah.
Now you need to find out the rest of the things. Now you need to find out the our first equation. You have to just try to put your analytical mind. You have to analyze, apply, and you have to evaluate. How can you evaluate all these three given equation in order to form the first one equation, the equation which I have highlighted with the yellow color, that you need to form?
Okay. Okay, yeah. Okay. So the end product is methane.
Yeah.
And according to Hess's law, you add up all of the enthalpies of like the process to get the final enthalpy.
Definitely.
Okay. So would you just add these three?
You have to add in such a manner that the LHS side we need to have the carbon, hydrogen, and RHS side there will be only methane. So you have to just reverse the third equation. If you reverse the third equation, if you just reverse the third equation, it will be like this: CO2 plus 2H2O gives methane plus 2O2.
Yeah.
Right?
Yeah.
And then CO2 and H2O both are this side, right?
Yeah.
And we need two of H2O. So you have to just multiply equation second by the factor of 2. If you multiply by the factor of 2, you will get the 2H2 plus O2 gives 2H2O. Are you getting that?
Yeah.
Yeah. So you have to just do this. 2 moles of hydrogen reacts with O2. 1 mole of O2 forms 2 mole of
2H2.
water.
Yeah.
Got it?
Yeah.
Okay.
Kind of. Yeah.
And the first equation, we have the
It's
only carbon solid plus O2 gives CO2. Now you add all these three. What you will get after adding?
So -394 plus.
Yeah, 2H2O will cancel out, as well as CO2. We are having CO2 will cancel out, as well as O2 plus O2. 2O2 will cancel out. Only the remaining part is carbon plus 2H2. Only the remaining part is, can you see that?
Yeah.
Only the remaining part is carbon plus 2H2 gives methane gas. That is what we were looking for. We were looking for this equation, right?
Yeah.
Okay, so now we have got the things what we required. Now you need to just add up the values with proper sign.
So you took out the O2s by just canceling them like that?
Because see, in the first reaction, O2 is in the product side. Here O2 is in the reactant side. So RHS, LHS will cancel out each other. If they are in the same side, they are in the same side, same reactant side. So they will be adding up, added, they will be added. And if they are in the opposite side, so they will get cancelled. It is like a subtraction.
Okay.
So 2 mole of O2, 2 mole of O2 will cancel out because 2 mole of O2 in the reactant side, 2 mole of O2 product side. So overall it will cancel out. 1 mole CO2 reactant side, 1 mole CO2 product side, cancel out. 2 mole water reactant side and 2 mole water product side, cancel out.
Okay.
Got it? Can you see all these things in the board?
Yeah.
Okay.
Yeah.
So you may ask
Yeah.
if you're having any doubt.
Okay. And you just, okay, 2H2O. Okay, no. So okay. So you're adding 286 plus
We are just adding minus 286. We are adding minus 286. No, not 286, because we have multiplied by the factor of 2. So 286 into 2 minus 394 and plus, because we have reversed this equation. So once we reverse the equation, sign will also reversed. So it will be plus 890.
Okay.
Plus 890 minus 394 minus 286 into 2.
Okay, so
Yeah, you can ask.
Okay, I'm just gonna go get my calculator in like 5 seconds.
Yeah.
Great. Thank you.
You're done?
Yeah, I'm back.
Okay, cool. So do you have any problem in this? You can definitely ask, because see, we need to form the first equation. This is the parent's equation, and this parental equation can be formed by the rearranging of these three equations. What we have given the data in the equation, the data in the question data, they have given combustion of carbon. So first equation is the combustion of carbon, second is the combustion of hydrogen, third is the combustion of methane.
Methane.
Yeah.
So we want to find methane. And so we just rearrange the other equations in order to find methane.
Yeah.
Right. Okay. So if you just write that again, because I'm going to write that again.
Okay.
Then you do.
I'll just go for the next page. I'll write for you.
Okay. So what we want to find is CO2 plus 2H2O makes CH4 plus 2O2, which is the parental equation. No, that's not the parental equation.
Yeah, parental equation is the formation of methane gas from its constituent elements. So carbon solid plus hydrogen gives methane gas.
Okay.
This is the equation A. Now we have got the three equations. Combustion means reaction with oxygen. Combustion of carbon, it produces CO2 gas. Equation first. Combustion of hydrogen. So we have to produce the 1 mole of hydrogen. So it is a combustion of hydrogen. Okay, this is equation second. And the third equation, what they have given the combustion of methane. Okay, and here we will have the 1 CO2, 2 H2O. Okay.
Yeah.
Can you see that?
Yeah.
Okay. So out of these things, what we have written in the board, you can definitely identify one thing, that key we can definitely rearrange 1, 2, 3 in order to get the A. So how we can get the A? We can get the A by reversing the third equation, multiply second equation by the factor of 2, because we need, obviously we have to we have to we have to just cross 2 moles of water to 2 moles of water. So we need to have the 2 mole of water, so we can definitely multiply by the 2. So it can be like this: 1 plus 2 into equation 2 minus 3. That is what I have done in the previous part. Okay,
Yeah.
you can do step by step, no problem. So I have just summarized the things in a particular brief manner. So I think you are able to
Yeah.
understand that.
Yeah. Yeah. So the equation 1 is C plus O2, right?
Yeah.
Which goes to CO2. And then equation 2 would be multiplied by 2 to get 2H2O, which is what we need. And equation 3, we just reverse it. Which is cool. And then you cancel out the O2s here, here, and here. Okay. And so we're just left with, and then we can cancel out carbon and water as well. I mean, carbon dioxide and water as well.
Yeah, definitely. See, when you just reverse the equation third, carbon dioxide and water will comes to the reactant side, methane and O2 goes to the product side. Now you can definitely ask the question, sir, why did we reverse? Why did we reverse this equation? Because we want methane in the product side. We want methane as a product. And here methane as a reactant, so definitely we can reverse. So once we will reverse, so it will be like a -3. Reversing means you are reversing the equation, so you are just applying the sign of minus.
So what is left is carbon plus 2H2 is equal to CH4, which is what we wanted.
Yeah, we wanted this only, the first one, the parental equation.
Okay, and now we just add up the enthalpies the way that we did them.
Yeah.
Okay. Cool.
Because we want methane as a product, so we have just reversed the equation third. So that is the -3. We have to cancel out 2 mole of water molecule, so we have multiply with the 2 of equation second. So 2 mole of water molecule will cancel out, and we can go for the addition of all three like this. So we will be getting the final equation.
Yeah. And then, okay, yeah. Okay, great. Okay, sure.
Any doubt you may ask?
Okay. No.
Cool.
No.
Any doubt?
No.
So I believe now you are having the basic understanding how to apply the Hess law.
Kind of, yeah.
Because we need to only form the given equation by rearranging. The important word is rearranging. How good you are in the rearrangement, definitely you will be a rock star of thermodynamics. You can definitely apply the Hess law.
Okay. 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 But okay, so from the rearranging, we know how to find this equation that you've written at the bottom.
I have written at the top how to find this equation.
No. I mean, like, yeah, but we know how to do this by doing this.
Yeah, definitely. We have to, yeah, by doing, yeah, this is the main step.
Okay. Okay. Kind of. Sure.
Any doubt here?
No.
No, you can ask if you have doubt. I want you should have a strong command. We will go the little slow, no problem, but your command should be strong.
So when I understand we're minusing 3, but from these 3 equations that we just did, how do we figure out that we have to -3?
Okay, So that is what I have told you in the beginning step. Can you see in, can you see
because we have to
here? Yeah, here the methane gas is the reactant side,
yeah,
but in the final equation, the methane gas is in the
positive side.
product side. So if we wanted the product, we have to reverse the equation. If we will reversing the equation, it will be like this. Now CO2
Oh, and then
plus,
this
yeah, now it's become product.
okay, and then so we know we have to add up all the enthalpies because we're adding carbon plus 2H2 and making methane. And okay, wait. Is it possible to say that this equation could, okay, can you say that C plus 2H2 negative minus CH4 is equal to 0 or whatever?
Yeah,
Does that
yeah,
make sense?
yeah. That's okay. That is how you can go from the mathematics part. 2 hydrogen minus CH4 equal to 0. No problem. You can say this is the mathematic form. So this CH4 is like a product side. When you bring the product in the reactant, that is obviously the reverse.
Okay. Okay, that makes sense. It makes sense. Thank you.
Okay.
Yeah.
You got the everything in the detail.
Yes.
Okay,
Yes.
cool. So this is how you have to, you have to rearrange the reactant in order to make the parental equation what they are asking in the question. Cool. Yeah. So we have done your work question in the worksheet. They have given your worksheet. Okay.
Yeah.
And then they heat energy mass into specific heat into temperature. Okay. So now we will go for the calculation of enthalpy changes. Calculation
Okay.
of enthalpy changes. I hope it's clear to you, right?
Yeah.
Okay,
Mhm.
cool. How to erase all this? Do you know how to erase all this?
Oh, yeah, sure.
Cool. Now, calculation of change in enthalpy. Calculation of change in enthalpy. Okay.
Mhm.
So, suppose we are having a body. In the body, we are going from A to B, and temperature is changed from T1 to T2. So delta T is equal to T2 minus T1, and during this temperature change, there will be a change in enthalpy because enthalpy is the function of temperature. Enthalpy is the function of temperature.
Temperature.
If there will be change in temperature, definitely enthalpy of the process will be changed. Okay. So as we know, the enthalpy delta H equal to QP, heat supplied at constant pressure. Heat supplied at constant pressure. Okay. So delta H is equal to Q into delta H is equal to Q. That is the heat only. Delta is the heat content at constant pressure. Delta H is the heat content at constant pressure. QP is equal to mass into ms into delta T. What is mass? Mass in gram, kg, mass in kg. What is S? S is the specific heat.
Okay.
A specific heat. Specific heat means heat of the 1 gram of substance. Specific heat means heat of the 1 gram of substance. Okay?
Heat of the 1 gram of substance.
Yeah, that is the specific heat. Now you can put it like this: S is equal to Q upon M into delta T. If M is equal to 1 gram, delta T equal to 1 degree Celsius. So heat becomes specific heat. Heat become a specific heat. So you can define you can define very well. You can say the amount of energy required to raise the temperature of 1 gram of water, to raise the temperature of 1 gram of water from 13.6 to 14.6. This is the standard definition for specific heat. What is the standard definition? So you can write in the copy also, I can write here also.
Okay.
Specific heat is it is the amount of energy required. Specific heat is the amount of energy required to increase the temperature of 1 gram of 1 gram of water.
Okay.
Increase the temperature of 1 gram of water from 13.6 degrees Celsius to 14.6 degrees Celsius. It is the amount of energy required. So as I told you, S becomes Q if M and delta T becomes 1. So M becomes 1 gram, delta T 1 degree Celsius. So it is the amount of energy required to increase the temperature of water. The specific range is 13.6 to 14.6 degrees Celsius.
Okay.
Any doubt you may ask?
That's what specific heat is, which is the amount of energy required to increase temperature from 1 gram of and then the enthalpy is equal to the constant pressure.
Enthalpy is equal to the heat at constant pressure, the heat of system, the heat content of system at constant pressure. Enthalpy is the total heat content of any reaction at constant pressure.
And the heat content of system at constant pressure is equal to the mass times the specific heat times the enthalpy.
That's right.
Like
That's right. QP is equal to mass times specific heat times delta T. MS delta T.
right.
Oh.
Okay. Okay, cool. I get that.
You got that?
Yes.
So Q is equal to MS delta T. S is equal to Q upon M into delta T. M becomes 1 gram and delta T becomes 1 degree Celsius. 1 degree Celsius, 13.6 to 14.6. This is the standard definition. Okay, experimental definition. Okay? Got it? Okay, so now I think you got this concept of enthalpy change. So delta H is equal to M times S times delta T. So shall we have a question on this?
Sure.
Yeah, cool. So we will go for the application part where you can analyze, evaluate, create something good, and that is how it will improve your concept grip, right? Yeah, here we are having a okay. So I will go for this question. Question number 2. I'll take the question number 2. Okay.
Yeah, sure.
So I have pasted a question here. I think you would be able to,
I can see it.
Yeah, see that clear, right? Yeah.
I can see it. Okay. Okay.
So I'll read a question for you. A student
Sure.
used to sample a calorimeter to determine the enthalpy change for the combustion of ethanol. So it's a combustion process where ethanol reacts with oxygen, forms carbon dioxide and H2O, right? So here it's a combustion process. We are having a 250 gram of water. When 0.690 gram or 0.15 mole of ethanol was burned, it produces a temperature rise 13.2 Kelvin in 250 gram of water. Calculate the enthalpy.
Okay, so the temperature change will be a positive 13.2 Kelvin.
Yeah, temperature rise is always positive, but enthalpy could be negative or positive.
Yeah. Then the mass would be 250 grams multiplied by the specific heat.
What is the specific?
We need to calculate the specific heat.
It's a 4.8.
Always?
It's a constant data. A specific heat is a constant for water. For water is always constant, 4.8.
Oh, it's constant.
Yeah, for water is always constant. That is 4.18. You can see this
Okay.
4.18.
Yeah. Okay, great.
So specific heat of water is constant. Specific heat of all medium is constant. So for water, it's 4.18.
Okay. Okay, and the temperature has to be in Celsius.
Yeah.
Okay.
No, temperature can be in Kelvin, no problem.
Then
Because
it's 14.
because we are always taking the delta T, the change in temperature. We are not taking the temperature. We are taking the change in temperature. So change could be in Kelvin or degree Celsius, doesn't matter, because change will be always the constant, right?
Yeah.
Specific heat is 4.18 joule gram inverse Kelvin inverse. So now enthalpy heat evolved at constant pressure will be m 250 gram of water. So you have to convert into kg. Then
Yeah.
4.18 into
13.K.
13.2 K. You will get the QP.
It's like 13.79.
What you getting? 18?
13.79 or 13.8.
13.8. Now you are getting this value as a kilojoule. Got it?
Yeah.
Now you have to find this value kilojoule per mole. So you have to get the value in per mole. So delta H, this is the QP. Enthalpy is always defined for the 1 mole. So how this many moles we are having this much energy. 0.15 mole has heat content QP 13.8 kilojoule. So 1 mole has QP, that will be the 13.8 divided by 0.015. Then you will get the answer. You will get the answer in mole, in kilojoule mole inverse. In kilojoule.
Can you explain it from the
Okay.
converting
Okay. So as I told you, enthalpy is always defined for the 1 mole. Amount of heat required to form 1 mole of substance is enthalpy of the substance, right? So this much heat content we have got for all the 0.15 mole, because the mass we have put 250 gram. So for all the 0.15 mole, we have got this value of heat. Okay?
Yes.
Now we need to find out the value of enthalpy per mole. So delta H will be the 0.05 mole, means for 1 mole we have got 13.8. So for 0.015 mole, we have to divide by the 0.015 mole. For this many moles, 0.15 mole, the heat content is 13.8. So what would be the heat content for 1 mole? What would be the heat content for 1 mole? It will be 13.8 divided by 0.015.
The heat content for 1 mole is equal to 0.015.
It would be equal to the given energy, given heat, 13.8 divided by the total number of mole. Because see, 0.15 mole got the heat content, that is 13.8. So we have to apply the unitary method. 0.15 mole has got QP this much. So 1 mole will be QP by 0.015.
Yeah, got it.
Any doubt you may ask?
No.
Got it? Do you have any doubt?
No.
So I think now application part is getting clear to you, right?
Yeah.
Yeah. 13.79. When they will divide by the 0.015, you will get the 920 kilojoule mole inverse.
Yes. Yeah. Kilojoule mole inverse. So it's negative 9.920.
Yeah, it's negative. Got it? So I think now you are getting the little confidence in calculation of change in enthalpy by ms delta T formula, right?
Yeah.
So today we have learned the formula, and this formula is having an extensive delta H is equal to m into s into delta T. Okay?
Yeah.
Okay. And also then after that, what else you have in the syllabus? Let me check that. Where it has gone.
Standard enthalpy change of formation, standard enthalpy change of combustion, and then just enthalpy cycles, which we did, and then bond and enthalpies. Okay.
Enthalpy of formation, combustion, endothermic, exothermic, heat and temperature, Q is equal to ms delta T. Okay, formation. Okay, I'll explain the formation. What is the meaning of formation? Formation means a formation of a compound. So enthalpy means 1 mole. So enthalpy of formation of any compound is defined as delta FH. Enthalpy of formation of any compound, it is the amount of energy. It is the amount of energy required to form 1 mole of a compound from its constituents elements in their most stable natural occurring form. Okay, form the elements in their most stable natural occurring form. Cool, eh? Suppose
yes,
if I write carbon graphite plus O2 gives CO2 gas. O2 is gas, carbon graphite. Carbon diamond plus O2 gas gives CO2 gas. Carbon coke plus O2 gas gives CO2 gas. Okay. carbon fullerene. Fullerene is a allotrop.
Yeah.
Plus
Yeah.
O2 gives CO2 gas. Can you tell me out of these four reaction, which reaction defines the enthalpy of formation?
Well, it would be at their most stable occurring form.
Yeah, it will be most stable natural occurring form. So in nature, carbon exists as a graphite, diamond, coke, fullerene.
Yeah.
So which form is the most stable?
Graphite?
Yeah, graphite is the most stable natural occurring form because diamond is a most hard solid, but diamond is thermodynamically not stable. Diamond thermodynamically not stable. Only graphite is thermodynamically stable. So the compound which is thermodynamically stable at its natural occurring state, for that Gibbs free energy formation will be zero. The Gibbs free energy for graphite will be zero. Graphite is most thermodynamically stable. So the correct answer is graphite. Okay?
What is G again? I mean, no, I get that. So just to recap, the enthalpy of the formation of a certain compound is equal to the amount of energy required to form 1 mole of the compound from its constituent. Okay.
Constituent elements in their most stable natural occurring form.
Okay.
Got it?
Yeah.
Okay. If I say you have to find out the enthalpy of formation of HBr, and I write H2 plus Br2 gas gives, just a minute.
Yeah, of course.
Hello. Okay, so H2 plus Br2, we are getting 2 mole of HBr gas. H2 plus Br2 liquid gives 2 HBr gas. Then half H2 plus half Br2 gas gives HBr gas. And then half hydrogen gas plus half of bromine liquid gives HBr liquid. Cool. Out of this 4 reaction, can you explain which reaction defines the enthalpy of formation of HBr? HBr gas, sorry. HBr existing gas. It's a good question.
Okay, so that would be its constituent elements at their most stable form.
Yeah, that's right. Most
so
stable.
Hydrogen gas would be most stable in the
hydrogen,
first 2.
Yeah, hydrogen exists as a gas, no problem. But at room temperature, because all the thermodynamics activity is being studied at 298 Kelvin, at 25 degrees Celsius. So at room temperature, bromine exists as a liquid. Bromine doesn't exist as a gas. Bromine exists as a liquid. Okay. This is an interesting fact. You must know this. Okay. So now we have the gas, this one and this one. You got 2 options. Now which option you can opt? First, second, third, and fourth. Which one will be your choice?
The fourth one or the second one?
No, you must be insured yourself. You must be confident enough to give me.
Bromine needs to be a gas. I mean, bromine needs to be a liquid at room temperature, and then hydrogen needs to be a gas. So from that, we know it's either 2 or 4, and then it has to form 1 mole, so then it has to be 4.
Yeah, it has to form 1 mole. Otherwise, everything is okay. Everything is right. Constituent element in natural occurring form, gas and liquid. Check, check. But here it's 2 mole, not check. Here everything is here also 1 mole. So formation of 1 mole defines the enthalpy of formation from its constituent atoms in most stable natural occurring form.
Okay.
So are we done today? I think today you have learned a quite good concept of thermodynamics.
Yes.
So now,
Just quickly, all thermodynamics occur at 298 Kelvin, right?
Yeah.
Okay, good. Great.
Okay. So if you have still doubt, Maya, you can ask your doubt. Do you have any doubt?
No, can I just write down the enthalpy of formation of compound formula one more time?
Okay.
On the last.
This one you want?
Yes, thank
Okay.
you. Does that say change of temperature?
Change
This
in temp.
thing?
Which thing?
What is?
Temperature where? No, it is the amount of. It is the amount.
Okay.
Okay.
Oh,
Sometimes. Yeah, it is. It is
Okay.
IT. Sometimes
Sorry.
my handwriting becomes like the doctor handwriting. It's like a doctor prescription.
Yeah.
Mm.
Got it. Thank you.
Yeah. So always remember the constituent atom should be exist in the most stable natural occurring form.
Okay.
Okay. So we will
Yes.
meet again on Friday, right?
Yes.
Okay. Till then, you just keep on practicing the questions from your book, and we will complete this chapter in the next class. We will taking the. I think you have entropy. Do you have entropy in this section? I think you don't have entropy.
It's not written.
Yeah, it's not written.
Yeah, it's not written.
So you don't have entropy, right?
I don't think so, no.
But IBHL, you know this Dibya in Dibya syllabus there is a entropy.
Yeah. Yeah, HL might have entropy.
Yeah.
I don't think I will.
Entropy is also a good concept.
Okay.
Okay. So till then, you keep on practicing and be safe. Be in the home. Keep on smiling. See you in the Friday.
Thank you. Goodbye.
Yeah. Bye bye.